Very good afternoon, everyone. Am I audible? Am I audible to you? Okay. So a very warm welcome to Q&A session, and we are doing chemical reactions and equations. And we have already started types of chemical reactions, right? This is something we have already started. Okay, so in the types of reactions in the last session, we discussed about the combination reaction, isn't it? The prerequisite for this session would be chemical formula. I hope you started learning about the chemical formula because in the last session you people were struggling. Okay, so if not, still you have the time, take out the class ninth book, Atoms and Molecules, that table of ions. And then balancing chemical equation. This is something we have already learned about. Okay, so we are doing chemical reactions, and from this particular topic, you can get 3 to 4 marks question. So we will be discussing about decomposition reaction. So basically, what is decomposition reaction and what are different types of decomposition reaction? This is something we will be discussing in this particular session. Okay, let's start now. So decomposition reaction is just opposite of combination reaction, isn't it? So where a reactant splits up into more than one product, so two or more products. Fine. So a reactant actually gives you reactant splits up into two or more products. That is called decomposition reaction, and it is definitely opposite of combination reaction. Fine. So if you want to note down the definition, you can. Is there some change in the color? Have Is it or no difference? I'm finding more blue color on my screen now. Anyway, coming to the types of decomposition reactions. So basically, decomposition reactions need energy, right? So I can simply say it is endothermic reaction. Fine. So our decomposition reaction is, wait. Yeah, so decomposition reaction is endothermic reaction. Okay. So when I say endothermic means energy is absorbed during the process, or heat is absorbed during the process. So decomposition reaction is actually endothermic reaction. Always remember, whenever bonds are broken, right, when we break the bonds, it requires energy, and when a bond is formed, then energy is released. This is something general thing I'm telling you. Okay. So if it is endothermic reaction, and remember, when in a reaction heat is released, okay, this is something uh, I'm telling you here. In a reaction, when heat is, first I'll tell you about the absorbed. Heat is absorbed, we write it like this: del H is equal to positive. Del H is positive. Okay. And in reaction, we write like this: A plus B plus energy, right? It will be written as energy, or it can be written as del H is equal to product. Fine. Whereas when heat is released during the during a reaction, right? So we write it del H is equal to negative. and we write it like this: A plus B gives P plus del H, means and heat is released, energy is released during the reaction. Okay, so the first one what you just saw is for the endothermic reaction, and the second case is for exothermic reaction. Am I clear? Am I clear about it?
Yes, ma'am.
Okay, so please note down. Please note down, then I'll erase it. Okay, so I think I should erase it now.
Yes, ma'am.
Okay, so as I said, decomposition is endothermic reaction. So the energy is provided in different forms, like in the form of heat, right? When you provide energy in the form of heat, you call it, just give me a second. Yeah, so when you provide energy in the form of heat, you call it thermal decomposition, right? We call it thermal decomposition. That animation has been left there. Okay, just give me a sec. Okay, so second is light energy. When we provide energy in the form of light, then it is called photochemical decomposition, right? And third, when we provide energy in the form of electricity, then we call it electrolysis. Okay, so here we got three different types of decomposition reaction based on the type of energy required to carry out decomposition. So first is thermal decomposition, which takes place in the presence of heat. Second is photochemical decomposition, which takes place in the presence of light. And third, electrolysis, which takes place in the presence of electricity. Clear? Please note down.
Yes, ma'am.
Okay, so if you have noted down, I'll just move ahead with the first one, that is thermal decomposition. Okay, so here is the first example of thermal decomposition. Now, in this example, what are we observing? Okay, let me come to the board because otherwise I'll be hiding it. Okay, so in this particular reaction, what are we doing? We are heating calcium carbonate and we expect it to undergo decomposition. So I'll be saying it is the example of thermal decomposition. Okay, it is the example of thermal decomposition. Okay, so here in this setup, in this activity, we have taken a dry test tube. Okay, we have a dry test tube, and in this dry test tube, we have taken calcium carbonate. Now, about the calcium carbonate, I have already explained it, but then again, I'll be telling you about this. When we talk about the calcium carbonate, no, uh, marble, chalk, limestone, they all are different forms of calcium carbonate. Okay, so chalk, marble, limestone, they are nothing but calcium carbonate only. So in this particular reaction, we have taken limestone. Okay, we have taken limestone in this particular example. So this is a dry test tube. No trace of water is present there. And then what we do, we are going to heat it. In another test tube, we have taken lime water. Lime water is what? Aqueous solution of calcium hydroxide. Okay, you have excess of water present in it, so aqueous solution of calcium hydroxide is present in the next test tube, and they both are connected with a bent test tube, u-shaped tube actually. It both the test tubes are connected. Now we are going to heat the tube containing calcium carbonate. So what do we observe here? A gas is a gas is evolved during it. It goes into the other test tube, and the solution, the lime water, turns milky, right? It turns milky. I'm again telling you what is happening. Again, I'll show you the activity here. We are heating calcium carbonate, means limestone, in a dry test tube, and we observe a gas being evolved during this, which goes through this tube into the next test tube, and the lime water turns milky. Now the question here is, why does lime water turns milky, right? So let's answer this question now. So the reason behind it that lime water turns milky, because calcium hydroxide, that is your lime water, okay, that reacts with carbon dioxide, which was actually evolved during the during this decomposition of calcium carbonate, okay, and it forms calcium carbonate plus H2O. Now this calcium carbonate forms white precipitate. It doesn't dissolve in water, it is insoluble in water, so it turns lime water milky. Am I clear?
Yes, ma'am.
So basically, when the lime water turned milky, no, this is the test for detection test for CO2, right? It is the detection test for CO2, which is known as lime water test. It is called lime water test, in which lime water turns milky. How does it turns milky? Because CO2 reacts with calcium hydroxide and forms calcium carbonate, which is insoluble in water, and it forms white precipitate. So it is the detection test for CO2, which tells us that during this reaction, CO2 gas was formed, right? So actually, what was the reaction? What was the reaction when calcium carbonate was heated? So basically what happened, when the calcium carbonate was heated, CO2 gas was evolved, and calcium carbonate actually turned, not turned actually, when it was heated, it gave the residue of calcium oxide. It gave the residue of calcium oxide. So what is the reaction going on here? Calcium carbonate, which is solid in state, when you heat it, it undergoes decomposition with the help of heat and forms calcium carbonate and carbon dioxide, right? So calcium oxide is nothing but we call it quicklime, right? We call it quicklime. So this reaction has a very much importance in the cement industry, right? It has importance in cement industry. Why is it so? Because cement requires calcium oxide, right? The calcium oxide is the component of cement. And how is calcium oxide obtained? By this particular reaction only. Actually, the limestone is being heated, which gives quicklime. Am I clear?
Yes, ma'am.
all the important informations are given in this slide regarding this reaction, all the information. So please note down each and every point. Okay, while you are writing, I'll be back in 1 minute. Okay, so please write each and every point. Okay, done. Shall I move ahead? Okay, fine. So next example. So again, this is the another example for thermal decomposition, where you are heating ferrous sulfate. Fine. So here we take a test tube in which ferrous sulfate, which is actually green in color, right? Green crystals. So the green crystals, ferrous sulfate, that is called, actually its actual formula is FeSO4 dot 7H2O, right? FeSO4.7H2O, where the 7H2O are the water molecules which are associated with the compound ferrous sulfate. So we call them water of crystallization. Right, we call them water of crystallization, these 7 molecules which are associated with one molecule of the compound, right, ferrous sulfate. Okay, so this is a FeSO4.7H2O, which is green in color, and we call it green vitriol. It is known as green vitriol. Okay, fine. So when we heat it in the dry test tube, what do we observe? We have to observe two things. First, it turns white in color, right? It turns white in color. So when it turns white in color, why is it so? Because on heating, it loses those 7 water molecules and now it has become FeSO4, anhydrous. No water molecule associated, no water molecule of crystallization is present with it. So it turns white. Okay, the crystal becomes white. And now you have to smell also. Okay, so what kind of smell do you get? You get unpleasant smell, a smell like burnt matchstick, right? A smell like burnt matchstick. Okay, so when this smell comes, another thing what happens, the white crystal turns reddish brown in color. The white crystals turns reddish brown in color, means they got decomposed. Now, what is that reaction? FeSO4 on heating gives ferric oxide, Fe2O3. That is ferric oxide. Okay, so just listen this thing. FeO, when I write FeO, it means it is ferrous oxide. I believe I told you about it. So why ferrous oxide? Because here iron is in +2 state and here iron is in +3 state. So that's why we are calling it ferric oxide. Okay, so I'm not writing it. Ferric oxide and plus SO2 plus SO3. So sulfur trioxide and sulfur dioxide, both are gases which escape. Now the ferric oxide actually gives reddish brown residue. I am calling it residue because here is something left behind. It's not precipitate which is formed during the reaction when you mix two solutions. It is a residue leftover thing after decomposition. Okay, so Fe2O3 gives you reddish brown residue. Sulfur dioxide gives you the smell. That unpleasant smell comes from the sulfur dioxide. But this reaction is not balanced yet. So to balance it, I have to put 2 here, right? So here it is solid in state and ferric oxide is also solid in state. SO2, SO3, both are gases in nature. Am I clear? Am I
Yes, ma'am.
clear?
Clear.
Okay, so let me repeat this once again for you. If you have any doubt, just do let me know. We took ferrous sulfate crystals, which are green in color actually, and we call them green vitriol. It has 7H2O molecules associated with it, and these molecules are called water of crystallization. So when we started heating it, the green crystals turned white in color. Why? Because the crystal actually they lost water molecules. So now they become anhydrous and white in color. On further heating, ferrous sulfate gives you reddish brown residue of ferric oxide, sulfur dioxide, and sulfur trioxide. Sulfur dioxide gives you unpleasant smell, a smell of burnt matchstick. Okay? So please note down whatever you feel like. Everyone, noted? Shall I change the slide? Okay. Fine. So this was the second example of thermal decomposition. Let's move on to the next example. But before that, let's do this question. A student heats a sample of ferrous sulfate in a test tube and notices the color change along with release of a gas. What is the color change and what is the gas released? What should be the answer? B means green to brown, sulfur dioxide, sulfur trioxide. Exactly. The right answer will be B here. We have just done, right? Very good. Okay, so now coming to the next example again, that's the third example for the thermal decomposition. I am picking all the example given in NCERT which are supposed to be asked in your exam. Okay, so thermal decomposition of lead nitrate, where we are heating lead nitrate. So you can see lead nitrate is actually transparent, colorless crystals, right? Lead nitrate, colorless crystals. And what is the formula of lead nitrate?
PbNO3.
Whole twice. Okay, PbNO3 whole twice. So when you start heating it in a dry test tube, you find brown fumes coming out of it, right? You find brown fumes coming out of it, and those brown fumes are nothing but the fumes of nitrogen dioxide gas, right? So always remember, whenever you have brown fumes, they will be of NO2 gas, right? So it means some reaction has occurred. And what is the reaction here? PbNO3 whole twice, which is solid in state, colorless. When you heat it, it gives you PbO. Okay, now PbO is actually yellow. Okay, so it's a yellow residue left behind. Now, nitrogen dioxide. Okay, so this is solid in state. Then nitrogen dioxide, which is gaseous in state, and it gives you brown fumes. And also you get oxygen gas. So this is whole of the reaction, but this reaction equation is not balanced. So to balance it, I have to write 2 PbNO3, 2 PbO, 4 NO2 and O2. Now it is balanced. So they can ask you this particular reaction and give you XYZ. Now what will be in place of, stoichiometric coefficient, you have to mention all the numbers, 2, 2, 4, like this. Okay. So I hope this reaction is clear to you.
Yes,
Clear?
ma'am.
Okay, fine. So these are the three examples that you should know, and each and every point which is written in the slide, everything that should be, memorized by you. Okay, so we are done with the thermal decomposition here. Let's do this example. A student heats lead nitrate in a test tube and observe gas evolution. Which observation confirms the presence of nitrogen dioxide? A pungent gas is released, which turns moist blue litmus paper red. A colorless gas is evolved, which supports combustion. A reddish brown gas is released with a choking smell, or the gas turns lime water milky. Exactly. Reddish brown gas is released, which is nothing but your nitrogen dioxide gas. Very good. Okay, so one more example which is out of syllabus, which is not given in NCERT but can be asked. Here we have sugar crystals. Okay, we have sugar crystals. You know that sugar is made up of what? Sucrose. the compound which gives, sweet taste to the sugar cane juice from which the sugar is formed, that sucrose has the formula C12H22O11. Okay, C12H22O11. Now you are heating this sugar. When you heat it, some vapors gets escaped and the crystals become black in color, means they get charred, like they get burned, right? So this is called charring of sugar. We call it charring of sugar, when where we are heating sugar and it is giving you black residue. Now what happens here, when you heat sugar, then sucrose C12H22O11, it releases all the hydrogen and oxygen in the form of water molecules. So can you tell me how many H2O will be released from this one molecule of sucrose? Can you think about it? How many water molecules will be released from this one molecule of sucrose? Think. Are you trying?
Ma'am, is it 11?
Very good, Joven. Very good. It's 11. So how is it 11? We have H22O11. So 11 H2O will be released. Fine. What is left behind? 12 carbon. Now this actually forms the charring. That black leftover, the black residue is of the carbon which is left. Okay. So this is another example of thermal decomposition. Fine. And the evolution of the gas which is happening there, that is nothing but the water vapor. So this is in solid state and this is going in the form of gas. Please note down. Have you written?
Yes, ma'am.
Okay. So we conclude that a decomposition reaction that is carried out by heating is called thermal decomposition, right? It is called thermal decomposition. And we have seen different examples. The first one, thermal decomposition of calcium carbonate, where the products were, what were the products?
Calcium oxide and carbon dioxide.
Exactly. And what was the test to determine the presence of CO2, to detect CO2? What was the test?
Lime water test.
Lime water test, right? And what is the industrial application of this reaction, decomposition of calcium carbonate?
It helps in the cement industry.
How does it? Cement requires a component quicklime, that is calcium oxide, which is obtained by this particular reaction. Okay, the next one is heating of ferrous sulfate. So what's the color of the ferrous sulfate crystal?
Green one. Green color.
Green. And what is the formula? What is the formula?
FeSO4.
Yeah.
I forgot.
Dot
7H2O.
7H2O. So these 7H2O molecules are called?
Green
What do
vitriol. Water of crystallization molecule.
Yes, those molecules are called water of crystallization, and FeSO4.7H2 is called green vitriol. Okay, so when we heat it, what happens?
It turns into white FeSO4.
Yes, it turns white. Green turns white because it loses those 7H2O. Okay, and when we further heat, what is the decomposition reaction occurring?
It gives ferric oxide, sulfur
What is the
dioxide,
color
and
of
sulfur
what is the color of ferric oxide?
reddish brown.
Reddish brown.
Okay, yes. And what are those two gases released with it?
Sulfur
Sulfur
dioxide and
dioxide.
sulfur dioxide.
SO2 and SO3. Very good. Okay, then we did heating of lead nitrate. So when we heat lead nitrate, what is the color of lead nitrate crystal?
White.
White, or you can say colorless. Okay. And when you heat it, brown fumes are evolved. Those brown fumes are of?
NO2.
Yes, nitrogen dioxide. Which other
Nitrogen
gases
dioxide.
formed with it? Which other gas is formed?
Oxygen.
Oxygen. And the color of the residue left?
Yellow color.
Yellow color. And what is the compound?
Lead oxide.
PbO, lead oxide. Okay, and then finally we did the heating of sugar, and that is called charring of sugar. And during the charring of sugar, the sucrose C12H22O11 gets decomposed into carbon and H2O vapors. Fine. So this is the thermal decomposition reaction where we saw 4 examples. So whatever was required, we did it one by one. So I'm not going to continue this after thermal decomposition. We have to do photochemical decomposition and the electrolysis, but in the next session. Fine. Right now, what are we going to do? We will be practicing the questions based on it. Okay. So in this session, we actually discussed, right? In this session, we actually discussed about the thermal decomposition. So I should rather say that in this session, we discussed about the thermal decomposition reaction. And in the next session, we will be discussing about photochemical decomposition and electrolysis. Okay, these two things we'll be discussing in the next session.